As typical computing systems will not last long enough to endure more major technological advancements, we will need something new. Introducing neuromorphic computing, mimicking the human brain and replicating them into computer chips. To understand the concept of modeling machines after our brains, let's talk about biological neural networks. Neurons transmit information to and from the brain in the form of electrical signals called action potentials, which are passed from neuron to neuron chemically via synapses. An action potential can be spatial, meaning that it's triggered by lots of inputs at once, or temporal, where inputs build up over time. Every time you practice the skill, certain connections and pathways in your brain strengthen, and that's how you learn. Spiking neural networks, or SNNs, are used in neuromorphic computing to meticulously model biological neural networks. The spike indicates an action potential being fired, so the signals that an SNN receives is like spikes. SNNs use rate coding, which measures the number of spikes that occur during a defined period. Consider chemicals triggering an action potential as inputs, messages passing as the processor, and finally the new chemicals as outputs. Having more than the two conventional output options opens up a lot more variety and creativity in computing.